I recently made a video where I did 10 product rule examples as quickly as I could, kind of a speed run. And in that video, I was forced to use the product rule to find the derivative of functions, and some of them didn't look like you should be able to use the product rule to find them. So in this video, I want to show you how you can manipulate certain functions in order to get them into a new form where you can then use a different method for finding the derivative of that function. In this case, we're going to be using the product rule, but this same method can be applied to use quotient rule or maybe sometimes even chain rule when it doesn't really seem like you should be able to do that. So without further ado, let's go ahead and jump on into the example and I'll show you what I'm talking about. So here's the example we're going to be going over today. We're going to be using the product rule to find the derivative of this function here, y equals x squared minus 3x plus 2. And you're probably thinking, the product rule doesn't work for this function, why would you try and do that? I want to prove a point here, and that is, in math, in calculus, there's oftentimes a lot of different ways to solve the same problem. So it's important when you're trying to learn how to do a new concept to not be afraid to try something that you're not sure if it's going to work, because maybe it will, and you'll probably learn something out of figuring that out. And that's especially true when it comes to finding the derivative of different functions, because when you look at this function, x squared minus 3x plus 2, you're probably thinking the easiest way to find the derivative of this function is to use the power rule. And you're right, that probably is the easiest. So, maybe it seems silly to try and force us to use the product rule here. But again, my point is there's oftentimes more than one right way to get an answer of a problem. So yeah, let's say we use the power rule here. We're just going to bring the power down in front, lower the power by 1, and then the derivative of minus 3x, it's just going to be minus 3. The derivative of a constant is 0. So yeah, finding the derivative using the power rule certainly works in this case, and we find that the derivative of this function is 2x minus 3. But let's say we want to use the product rule. Well, obviously, this function is not really in a form that seems conducive to using the product rule. Seems weird to try and use that because we don't have a product. We don't have one thing times another thing like we need in order to do the product rule. But what you can think about is how can we rewrite this function so that it is a product of two things? And if you're looking at a quadratic, a lot of times that can be done by factoring it out. So let's think about how we could factor this quadratic out. Well, we need two numbers that multiply to positive 2 and add up to negative 3. Well, that would be negative 2 and negative 1. So we can rewrite this function without taking the derivative, just simply rewriting this function in another form that's equivalent as x minus 2 and x minus 1. I'm sorry, I might have said negative 2 and negative 3. I meant negative 2 and negative 1. Negative 2 minus 1 is negative 3, and then negative 2 times negative 1 is positive 2. So if we were to factor this out, if we were to FOIL this, we would end up back here. So this function here is equivalent to the one we started with. And now look what we have. We have the product of two things. We have this thing times this thing. So we can use the product rule by saying that one of those is f and the other one is g. So if we're going to say f is x minus 2 and g is x minus 1, then we were to find f prime and g prime in order to apply the product rule, which again, I've written the formula for the product rule right up here. We would get the derivative of x minus 2 is just 1, and the derivative of x minus 1 is also 1. So then if we were to apply the product rule by multiplying across like this, multiply f times g prime, multiply f prime times g, we would get x minus 2 times 1, and then we would get x minus 1 times 1, so plus x minus 1 times 1, which x minus 2 times 1 is just x minus 2, x minus 1 times 1 is just x minus 1. So then to simplify this, we can just combine our like terms, and we find that the derivative here is 2x minus 2 minus 1 is minus 3. So we get y prime equals 2x minus 3, and that's exactly what we got up here by using the power rule. So this is a perfect example of multiple ways to find the derivative of a function. We can fit it into a form where a different method is usable. And a lot of times that's the case where you might be able to use product rule and quotient rule to find the derivative of the same function simply by manipulating the function into a form that works with product rule or a form that works with quotient rule. Of course, that's going to take manipulating because the product rule requires your function in a specific form, and the quotient rule requires your function in a specific different form. So there is going to have to be some manipulating to get from one to the other. But a lot of times that can be done. So if you have a method of finding a derivative that you like the best, sometimes you may be able to manipulate a different function into the form that allows you to use that method that you like. Well, I hope you found that video helpful, and you'll always keep in mind that there's usually more than one way to solve a problem. So don't be afraid to experiment and see what you can come up with, because honestly, that's the best way that you're going to learn this stuff. If you found this video helpful, please be sure to hit that like button down below. Subscribe too while you're down there, and hit that bell icon so you're notified of all my new videos. And together we'll keep crushing it all term long. Thanks, and see you next time.